Every time you pick up your phone, your dopamine neurons fire, not because of what you find, but because of what you expect to find. That anticipation, that pull, is not willpower failing. It is a Pavlovian loop running inside your mesolimbic pathway, and it has been training itself without your permission for years. Right now, your dopamine baseline, the tonic, steady-state level that determines whether you feel motivated or hollow, is likely lower than it was 5 years ago, and the things you reach for to fix that feeling? The scroll, the sugar, the binge, they are the exact stimuli driving it lower. Over the next few minutes, we are going to walk through exactly how your reward circuitry got hijacked, from the first receptor downregulation to the full neurochemical collapse that medicine now calls burnout. And then, stage by stage, the precise protocol your brain needs to rebuild. Your dopamine system operates on 2 frequencies. The first is tonic, a slow, steady baseline hum of dopamine molecules sitting in the synaptic cleft, keeping your prefrontal cortex online, your motivation intact, your sense that effort is worth it. The second is phasic, sharp, fast bursts fired by neurons in the ventral tegmental area every time something unexpected and rewarding happens. Wolfram Schultz's landmark research on reward prediction error showed exactly what triggers those bursts. Not the reward itself, but the difference between what your brain predicted and what it received. Get something better than expected? A phasic spike? Get exactly what you expected? Nothing. Get less. The neurons go silent, below baseline. That silence is the trough. And here is the first stage of the trap. When you scroll through social media, every swipe is a slot machine, variable reward, unpredictable timing. Your phasic dopamine system fires constantly, not because the content is extraordinary, but because the delivery is randomized. Your brain cannot predict when the next hit arrives, so it keeps firing. A study published in Nature demonstrated this mechanism directly. Acute overstimulation disrupts the balance between tonic and phasic dopamine patterns and impairs Pavlovian task performance. The consequence is measurable. Every phasic spike is followed by a compensatory drop, the dopamine trough, where your baseline falls below where it started. The higher the spike, the deeper the trough. And when you chain those spikes, notification, scroll, notification, sugar, scroll, you are not accumulating pleasure, you are draining baseline. Your brain responds the way any adaptive system would. It pulls receptors off the surface of the postsynaptic neuron, specifically D2 and D3 receptors, the ones responsible for experiencing satisfaction from ordinary effort. A Nature-published study on sucrose intake showed exactly this. Repeated high-stimulus consumption directly lowers D2/D3 receptor availability in the brain. This is receptor downregulation, not a metaphor, not a lifestyle concept. A physical reduction in the molecular hardware your brain uses to register that something was worth doing. Fewer receptors means the same amount of dopamine produces a weaker signal. So you need more, you scroll longer, you eat more, you chase harder, and each chase strips another receptor off the membrane. This is the first stage of the cascade. Your baseline has dropped, your receptors have thinned, and the behaviors driving both processes feel like relief. Because for a fraction of a second they are. But the adaptation is just beginning. By the time your receptor density has meaningfully declined, something else has shifted. Something most people never notice until it has already taken hold. Your cue-reward associations have been Pavlovian conditioned to extraordinary precision. The notification chime on your phone, the Netflix autoplay countdown, the red badge on the app icon, none of these are rewards, they are cues. And your dopamine system does not wait for the reward anymore. It fires at the cue. Schultz proved this decades ago. Once a reward becomes predictable, the dopamine burst migrates backward in time, from the reward to the earliest signal that the reward might be coming. Your brain has learned to want before you have even decided to act. This is not abstract. Harvard Health published a direct investigation into what they called doom-scrolling dangers, the measurable neurological consequences of compulsive digital consumption. And the evidence is now impossible to dismiss. A major Guardian investigation asked the question bluntly, is doom scrolling literally rotting our brains? Their conclusion, the evidence is getting harder to ignore. But here is where the cascade gets genuinely counterintuitive. The pathway responsible for this conditioned wanting, the mesolimbic pathway, running from the ventral tegmental area to the nucleus accumbens, is not the same system that generates liking. Dopamine drives wanting, seeking, craving. The actual experience of pleasure relies on a separate opioid system. So as your dopamine loop accelerates, you want more while enjoying less. You are reaching for your phone not because it feels good, but because your brain has been conditioned to predict that it should. And this is the neurochemical definition of burnout, not fatigue, not overwork, allostatic overload of the reward system, a state where the baseline has fallen so low that even rest registers as absence of stimulation, which itself triggers seeking behavior. You cannot rest because rest feels wrong. The mesocortical pathway, the branch that feeds dopamine to your prefrontal cortex for planning, focus, and impulse control, is starved. Decision-making degrades, motivation collapses, and the behaviors you use to cope are the exact stimuli perpetuating the cycle. Harvard Business School research framed this precisely. Burnout is not random, it is predictable, driven by specific environmental and neurochemical collisions. Frontiers in neuroscience went further. The brain's damage from constant overstimulation mirrors neurotoxicity mechanisms seen in substance abuse. Your reward system is not tired, it is structurally altered. And the most dangerous part? The trap feels normal. Now, the rebuild. And this is where the neuroscience becomes genuinely hopeful. Because the same plasticity that let your brain rewire toward dysfunction works in the other direction. But the protocol is specific, and the first step is the one most people get wrong. Before we go further, Harvard Health published a crucial reality check. The headline read, "Dopamine fasting, misunderstanding science spawns a maladaptive fad." The popular version, locking yourself in a room, staring at a wall, avoiding all pleasure, misunderstands the mechanism. You are not fasting from dopamine. You cannot. Dopamine is produced continuously by your brain. What you are doing is removing the supraphysiological stimuli that drive the phasic spikes responsible for receptor downregulation. The goal is not zero stimulation, it is calibrated stimulation, replacing passive, high-spike behaviors with effort-gated ones. Here is what the evidence supports. First, eliminate stacked high dopamine inputs for a defined period. No simultaneous music plus phone plus caffeine plus sugar. Each of those alone produces a moderate phasic spike. Combined, they produce a supraphysiological surge your receptor system cannot sustain. 21 to 30 days of unstacking these inputs allows D2 receptor density to begin recovering, the neuroplasticity window for upregulation. Second, replace passive consumption with effort-based dopamine release. When dopamine is released as a consequence of effort, physical exertion, skill acquisition, problem solving, the phasic burst is paired with a different contextual signal. The brain begins to associate reward with effort rather than with cues. Exercise is the single most potent intervention here. Running, swimming, resistance training, each produces dopamine release through the nigrostriatal pathway that does not carry the same trough penalty as passive consumption. Harvard Medical School found that even simple movement like dancing produces measurable beneficial changes in brain function and dopamine balance. Third, and this is the most overlooked element, structured low-stimulation activities, not doing nothing, doing something absorbing at low intensity. Harvard research demonstrated that hobbies are directly tied to sustained well-being and happiness. This is the Pavlovian recondition in reverse. Instead of cue to anticipation, passive reward trough, you build cue to effort to earned reward stable baseline. The same associative learning that trapped you becomes the mechanism that frees you. And the nutritional foundation matters. Tyrosine, the amino acid precursor to dopamine, is rate limited by dietary intake. Eggs, fish, almonds, avocados, not as supplements to megadose, but as substrates your synthesis pathway genuinely requires. Without adequate tyrosine, the rebuilding process stalls regardless of behavioral changes. Dopamine pathway intervention is not theoretical. Nature published research showing D1 receptor modulation is already being used as a therapeutic strategy in clinical settings. Your receptors are not permanently damaged. They are down-regulated, pulled inside the cell membrane, waiting. 30 days of effort-gated stimulation, unstacked inputs, and adequate precursor nutrition begins the upregulation process. By week 3, the same walk outside that felt meaningless starts registering. By week 4, sustained focus returns. Not because you are forcing it, but because your prefrontal cortex finally has the dopamine supply it needs. The cascade reverses, slowly, then unmistakably. Right now, inside your ventral tegmental area, dopamine neurons are firing, responding to every cue your environment has trained them to expect. The question is not whether that loop exists, it is whether you keep feeding it or start rewiring it. Next, what happens to your nervous system when you stop eating for 72 hours?